Question 3.34. Four identical point charges of 1.61 nanocoulomb are placed at the corners of a rectangle which measures 3 meter by 5 meter. If the electric potential is taken to be zero at infinity, what is the potential at the geometric center of this rectangle? So here you have a rectangle that has identical charges placed on each of its corner. The magnitude of the charge Q is 1.61 nanocoulomb, which you can write as 1.61 times 10 to the power negative 9 coulomb. And we need to find the potential at its geometric center. The geometric center of the rectangle lies at the intersection point of its diagonal. So if I were to sketch the diagonal for my rectangle, the intersection point will give me my geometric center C. We need to find electric potential at this point C because of the four charges. We know that electric potential V is given as KQ over R, where K is the Coulomb's constant, Q is the charge, and R is the distance of the point from the charge Q. This distance R from the geometric center can be shown in the figure as follows. From the charge Q to the point C, R, and it is equal for all the point charges. We know that electric potential at point C can be calculated by adding potential due to each of the charge. So I can write total potential at C to be equal to electric potential due to charge 1 plus charge 2 plus 3 and plus 4. All of these charges are identical and they are at the same distance from point C. So potential due to 1 has to be equal to potential due to 2, and same goes for 3 and 4. So instead of adding them individually, I can just write electric potential at C to be equal to 4 times V1. To find electric potential, we need to know what is the charge Q and the distance R. Q is given to us in the question. We need to find what is R. From the figure, we understand that the distance R is half the length of the diagonal. So if I were to call the length of my diagonal to be D, R is equal to D by 2. We can find D using Pythagorean theorem as we have the measurement for our rectangle, which is 3 meter by 5 meter. So we will find D as square root 3 squared plus 5 squared. That gives me 5.88 meter. And then we find R as D by 2, which is 5.88 by 2. That gives you 2.94 meter. After we find R, now we can substitute and solve for V. V we will write as 4 times V1. So that becomes equal to 4 times KQ over R. Now substitute. 4 times K is Coulomb's constant, 9 times 10 to the power 9. Q is 1.61 times 10 to the power negative 9 over the distance R, which is 2.94. And when you solve this, you get electric potential at the geometric center to be equal to 19.71 volt.